in metabolite identification, drug impurities, degradants, and in extractables and leachables, an analyst will typically use mass spectrometry to elucidate compounds. However, this technique only proposes a formula. Clues about the actual chemical structure are deduced by looking at the high-energy fragmentation, the chromatography, and the chemical context. This narrows it down to a number of probable isomers. Final structural confirmation, often by NMR, is time-consuming, expensive, and causes a significant delay in the whole process, because typically it is only after full elucidation that the compound is assessed for mutagenicity. Using ChemTunes.ToxGPS software, the analytical chemist can quickly screen all probable isomers for AMES prior to final elucidation and give an early alert to the expert toxicology panel. The workflow starts with the analyst drawing the isomers directly into the software. Alternatively, they can batch load from an ST file. The first stage is to see if there are any existing studies for the submitted structures in the database. This is of particular use for extractables, where there are commonly found compounds. The database includes 11,500 genotox studies, all of which have been assessed and curated by our toxicologists. The ECHA database is currently being added, and if the compound is not in the database, there is an inventory provided to indicate where you can find the study. There is a study for this compound, and to view, I click on the data details, and for AMES, in this study, the pool was negative. The next stage is to apply QSAR for AMES to the batch of structures. The main prediction components of the system are a rules-based prediction from known structural alerts, a statistical QSAR model, a statistical QSAR model based on a particular mode of action. This was developed in collaboration with the FDA, and nearest neighbor analysis. The software provides a robust and rigorous method for quantitative weight of evidence based on a combination of all these models using a statistical process, the Dempster-Shafer theory, into a single call of percent chance positive, percent chance negative, and percent uncertain. Back to the software. With a few clicks, we can do a prediction for AMES. All of these isomers have been predicted negative. However, if there is some doubt, the analysts can prioritize in their elucidation process, trying to rule out the most uncertain isomers first. The results of the scan can be exported to Excel. Your work can be named and saved to the database. There is also an admin facility to share your work with other users of the system. To summarize, the key points are: if positives are predicted, the toxicological panel can be alerted for their expert opinion much earlier in the process than is currently possible, thus greatly improving efficiency. If an isomer is found to be positive, the analyst can concentrate on trying to rule it out first by examining the MS2 or the MS3. If all isomers are negative, it may not be necessary to do the final conformational elucidation, especially in early drug development. And if you're doing extractables and leachables work, there is a huge database of curated genotoxic studies. This is a very brief overview presentation. If you would like further information, please contact us. I thank you for your attention.